Hello, everybody. This is my first video, and recording on my Chromebook, and I'm just gonna be doing my AP Stats, one of my example questions. So, right now, this is talking about random variables and expected values. So, it's saying a man buys a racehorse for $25,000 and enters it in two races. He plans to sell the horse afterward, hoping to make a profit. If the horse wins both races, its value will jump to $75,000. If it wins one of the races, it will be worth $50,000. If it loses both races, it will be worth only $10,000. The man believes that there is a 20% chance that the horse will win the first race and a 30% chance that it will win the second one. So, right now, let's highlight everything that is of significance here. So, he bought the racehorse for $25,000. That's the base value. He wants to sell it afterwards and make a profit. So if the horse wins both races, it'll jump to $75,000. So that's going to be another significant value. The second one, if it wins one, it'll be worth 50,000. That's another significant value. And if it loses both races, it's only worth $10,000. That's another significant value. There's a 20% chance that the horse will win the first race. So 20%, that's okay. That's another significant value, and same with 30%. Now, first, we're also going to want to add a chance that these won't happen. So he won't win the first race is 1 minus 0.2, which equals zero point 0.8. And then also 1 minus zero point 0.3, which also equals, and not, which equals 0.7. So we have those. Now we're going to draw our table because we want to put everything make everything organized. So first we're gonna put wins both. Then we're gonna put gonna the abbreviation for loss is gonna be L, and the abbreviation for win is gonna be W. So the probability that they lose the first one and win the second one, L1 W2, win the first one. Win the first one, lose the second one, and the probability that they get none. So that's that. Now we need to put the profit first. Sorry, my handwriting is really bad. And also, I don't like the way this Chromebook is. Anyway, so the probability of, let's just say X, which is the probability of this profit. And then we can add the expected value, which we're going to add down here. So the probability that they both win is 0.2 times 0.3 because the notation for this is probability, let's just say W1 and intersection W2. That means you have to multiply them both, which means 0.2 times 0.3 is 0.06. All right, so now we have the probability of them both, of the horse winning both the races. Then we have the lose the first one and win the second one, which is zero point 0.8. Remember, I'm going to circle that 0.8, 0.8 times 0.3, which equals, well, the notation for this is the probability of L1 and W2. So 0.8 times 0.3 is going to be 0.24. So now that we have room, we're going to do win the first one and lose the second one, which is 0.2 times 0.7, which equals, I know it equals 0.14, but I'm just so paranoid. I always have to check my work on my calculator. So anyways, 0.14. So 0.14. If you're really obsessive compulsive, just draw this chart and use straight lines, please. I don't want to upset anyone, but it's gonna be like that. Anyways, for the next one, the probability of none is going to be 0.8 times 0.7, which equals 0.56. There we go. Now we have all the probabilities. Now we have the probabilities. Now we need to find the profit. So we start at 25K. And if he wins both, it jumps to 75,000. So 25K was 75K minus 25K. It's going to be 50K. Right. So we're just going to make this the profit of 50K. Then the profit of winning only one of them, which makes it worth $50,000. The profit of that is just 50,000 minus 25,000. So minus 25K, which equals just 25K. So you can put that for both L1 W2 and W1 L2. 25K, 25K. Now, the next part is if it loses both races, it'll be only 10,000. So that's going to be 25K minus 10K, because you're losing 10,000. You're not losing $10,000. It's going down to 10,000 from 25,000. So that's just 15,000. All right. So now that we have a difference of 15K, we're going to put minus 15K because we're losing $15,000. It's going from 25,000 to 10,000. So we're losing 15,000. So now we just have to find expected values. So we're going to do the profit times the probability that that profit happens. So 50,000 first times 0.06 is 3,000. Then we're going to do 25,000 times 0.24, which is 6,000. Then we're going to do 25,000 times 0.14, which is 3,500. Then we're going to do negative 15,000 times 0.56, which is a loss of 8,400. So now we just add these all up. So we're going to do 3,000 plus 6,000 plus 3,500. And then we're just going to subtract that. I mean, not subtract that. We're going to subtract 8,400 from that. So the total payout ends up being 4,100. So our expected profit is 4,100. Shoot, hold up, let me erase that and make it more seeable. 4,100, which is correct.